Now let's look into reshaping and pivoting tables with pandas. This is the really fun stuff. We can really start to manipulate the data. So let's dive in. In the tidyverse and Hadley-Wickham style, the different operations are called verbs, and I really like that. I think it's a good way to think about it. So those verbs that we have in pandas are pivot, stack and unstack, melt, group by, pivot table, crosstab dummies, factorize, and explode. So it's kind of fun thinking of those verbs. These are all the things that we can do to data to transform it into how we need to have it to visualize or to do anything else with it. So there are some great visuals that the pandas documentation put together. So I'm going to use some of them. If you click on the pandas link, the pandas image above, it'll take you right to the docs there. The first that we want to talk about is pivot. So this is one of the most common operations on data. It's the first one in the docs, and this one, as it's implemented in pandas, isn't very general, but what it'll allow you to do is take a standard data frame without a hierarchical index and expand one of the columns, one or more of the columns, into a hierarchical column index. So here, right, we took the values, we took the index from foo, so we've got difference of 1 and 2. We've got columns of bars. So we took bar and we put it on the column. So we transformed it over to the column. And then the values we pulled out of Baz. So Baz, there was 1 through 6. So you can see that there's still 1 through 6, 1, 2, 3, 4, 5, 6 are what's in the data still. So this is a pretty common operation. And now we have the data in a different format to work with. So yeah, the visual, and keeping in mind, here what we're really doing is we're taking bar and we're pivoting it up, right? We're collapsing on foo on the common values of foo bar combinations. So foo and bar have, for one of foo, there's ABC of bar, right? And it will collapse those. If we tried to use pivot and there were too many values, so for example, if there was 2 entries for foo 1 and bar A, right, we'd actually get an error. It wouldn't know where to put it, right? So here, right, conveniently the data frame set up so that's not a problem, and we can go ahead and pivot this just fine. If there are more than one value, you have to do something with them. So you either, in general, you need to aggregate them. So we'll look at pivot table to do that, where we can aggregate numerical ones by, sum or count or whatever. And they don't have to be numeric. You can just count them. You can count them as well. The next pair are stack and unstack. So they're very similar to pivot. You will see that stack actually looks a lot like the opposite of pivot, and I would say that it's a lot like unpivot. Maybe it should be called unpivot, but what it's going to do is it's going to take the column index, right, and move that, or the row index, the column index, and move that down to a row index. So it's going to take the values of A and B, and it's going to put those down into a column. Again, still we have the same number of values. And of course, this will work, right? Because, we're not going to encounter duplicates in this way. Stack is designed to work with a hierarchical index. These are multi-indexes in pandas. One thing I really do like about pandas compared to our data frames is that they're very good about being explicit about the index objects. What is a multi-index? What is an index? It's not all hidden behind the curtain, right? You work with these objects directly. The counterpoint to stack is unstack, right? And unstack in this case behaves exactly like our pivot, but the difference is that unstack is working on a hierarchical index. So these are designed to work with hierarchical indexes, or multi-index means the same thing, and that's the difference between this and pivot, right? Otherwise, this looks a lot like pivot. Again, right, in this case, you would need to have, well, in this case, it couldn't be a problem that you have duplicates because your index is actually already hierarchical. So you don't have to think about that problem. But yeah, it's going to go in and actually pivot this. I think that the fact that it's unstack and pivot, like they're opposites, I'll have to put in a pull request for that one. Unstack can also operate on different columns, so you could actually unstack any level of the index. So the default is the last level. So the default, the first one we saw, this is just unstack, right? So it did the A, B column, the last one in order of the index. You could unstack the second one, and Python's 0 index, so unstack of 1 is actually going to be that second column. You could also grab it by name. Oh, and it says here, yeah, unstack of first. You could also grab it by name. It'd be unstack of 0, unstack of first. And you can do any of these, right? There's actually no, there's not a lot of trouble you can run into here in terms of duplicates because these are multi-indexes. So yeah, we can pivot things, we can stack and unstack, and melt is another interesting one, right? So this actually transforms the data into just a different storage format. So it's actually going to create a new column called variable, and you can set the name of that, right? You can set the name of the variable column to be anything you want, and the name of the value column to be anything you want. Those are options to the melt function. Right here, right, we're actually taking the height and weight, right, and we're making those as values. So here, yeah, you can have data of the format where you've collected, you've collected each of these one at a time, right? And that's how you want to see it, right? You could melt to that format from something that's on a person level. And then, of course, you can pivot back, right? If you want to get the opposite of this, right, you could use pivot, where you'd pivot with value column is value, the column is variable, right? And the index is first last. So you'd get the same thing there. Okay, so group by is another one I want to talk about. So here's a data frame, right? You've got a hierarchical column index and a hierarchical row index. So on the top, you've got the experiment number, the animal, X, I was going into experiment, A, B, none, A, animal is cat, dog, and then you got first, second, Barbaz, who, kooks, and 1, 2, 1, 2 for second. So anyway, yeah, you can think about how we were doing all these previous operations. We're starting with something that has 2 level indexes on both. All right. Oh, it doesn't look like the top one is actually a hierarchical index, right? Yeah. Okay. Anyway, what we can do here, you can actually see how group by can do really the same operations that you were doing in stack. We were doing in stack and unstack. So if we first stacked it, right? So think about what would happen if we stacked this one. So what it's going to do in stack, if we go back and look at this, what is stack going to do? All right, we have to think back to our image. So let's go back to our image, right? These are what, if you really bury in your head or print out and put on the wall, right, are going to help. So stack is going to take the column headers and it's going to put them into a row. Okay, so let's see, what is stack going to do to our data here? Stack is going to take cat, dog, and put them into a column. Okay, let's take the mean of 1, right? So it's going to take the mean across the second column. The second column here is still second, 1, 2, 1, 2, right? And then it's going to unstack it, right? So it's going to push the last index back to the last column index back to the columns, which is cat, dog. That's the one we stacked in and then unstacked. So here what this did effectively is grouped by all the different values of 1, 2. So you can see for 1, 2 and cat, dog, right? Well, the thing we lost was X, right? So 1, 2, right? It grouped those. And here the default for, well, not the default, we told it to take the mean, right? So in this case, right, we would have the mean for cat, we're gonna have the mean of 0.89 and 0.12 minus 1.20. So the mean of that's gonna be a little bit negative for the first one. So yeah, minus 0.15, a little bit negative for the first one there. If you're not following that, stop, pause the video, and just think about, what does that operation look like? You're taking the column, putting it up, taking the mean of the first one, right? So what are you actually going to collapse, right? Yeah, cool. All right. You could do the same thing with a group by. So the same code in group by, I have to scroll down here a bit, is right doing a group by on the first level, the second level, right? So we're grouping by 1, 2, and then we're grouping by level 1 on axis 1. So axis 1 is actually going to be on the column axis. So then we're just going to take the mean across, right? So I actually think that the group by is a lot easier to see. You're not moving things in, grouping, not moving things in, taking them in, and moving them back up, right? You basically are, but right, I think this is a little easier to see. Maybe I've spent more time in SQL, so the group by makes sense. But you can do the same thing in group by. And here's another example where you're doing the same thing with group by, and you can also combine it with stack. So if we take the data frame and we stack it, again, right, for stacking it, we're going to take the first column index, and we're going to put that in as a first top level index on the columns. We're going to put that in as a row index, and then we'll group by the second column index, right, and take the mean. So, you know, the stack, right, is going to pull in the cat dog, right? Okay. The group by, right, is going to group by the second level, right, which on our data frame I think was the 1, 2, and then it's going to take the mean, right? Cool. So we pulled in cat dog, took the mean across 1, 2. Cool. And right, it's the same thing actually as doing. Oh no, of course, it's a different thing. So if we do the mean, right, and unstack it, right? So if we take the mean on the whole data frame, right, that's going to respect the index. So it'll mean across all the columns, and then we can unstack it. So that would take the mean, it would collapse. In this case, right, it's going to collapse all of the columns, and then we'll unstack that back in. Yeah, cool. Is that right? We can double check. We keep exp and animal. And df.mean, right, that will collapse at default axis 0, take the mean across axis 0, and then to unstack the first level. So let's go back and check what unstack does. Yeah, so unstack is going to go ahead and push the column back to the row. So here, right, we're going to push, in this one, right, we're going to push the first column AB back up to the top. So if we go back and look at our data frame, right, pushing AB back up to the top. Okay, cool. Those are pretty fun ones, good ones to think through. Pivot table, right, I want to mention pivot table. It's the same as pivot fundamentally, right, or it kind of does the same thing conceptually, but it aggregates on numerics. So if you have more than one, if you have duplicates, you can aggregate. You can also pass, I guess to say aggregate on numerics. The default is to take the mean on a pivot table, but you can also pass a count, right, which is going to be like a cross tab, as we'll see. You could also take the sum, right? You could pass in any aggregation function you want. That's one of the arguments to pivot table. Crosstab, right? So it's convenience deputed compressed tab. It's actually the same as pivot table. It's a little less flexible than pivot table, if anything, because under the hood, it will go ahead and call pivot table. It doesn't have to have a data frame as an argument. It'll convert it to a data frame and then call pivot table. And it'll count. So let's see, basically, it's going to go ahead, if you do crosstab, right, it's going to be the same as taking pivot table of, you know, converting your thing to a data frame already. But index and columns, right, one index, one column. And then ag function is length, right? So you know, you're going to have an array, right? Just take the length of it, just count the array. And then fill in zeros where you didn't have values. Same thing. So yeah, it's going to compute a frequency table for us, which is, you know, often a very useful thing. Finally, there's 3 other functions that I want to mention: dummies, factorize, and explode. Sorry, typo. So dummies, right? If you have maybe a column that's ordinal or nominal, like cat, dog, right? What that's going to do is push it out to a column. So you have column for cat, so you had cat, cat, dog, cat, dog, cat, dog. And they push it out to cat and dog as columns, and then 0, 1 if they existed on that. So it won't change the number of rows, unlike stack and unstack. You'll keep the same number of rows. You would lose the column, right? You can actually choose to keep it if you want. We're going to create 2 more columns, which are 0, 1 if that column exists, or if that value is what's in the column. It's useful for like a machine learning thing if you want to have like a levels instead of yeah. Well, that's why you'd want it. And then factorize, right? So factorize, it's just basically if you have a column, right, and you want to take all of the values and convert them to integers, where, you know, all the A's become 0, the B's become 1s, right, for all the different unique values, right? It will replace, it operates on an array, but you can run it against a column, right, and it'll replace that column with the order in the unique level. So also handy for doing transformations. This one I think also useful for machine learning type tasks. And finally, the one I mentioned is explode. So sometimes if you're doing some of your operations on manipulating things, you'll end up accidentally with a list inside of one of the values. So you can actually explode those back out to a column. So if you have a column that actually has lists of values inside of it, right, you can actually expand those. And that's what explode will do for us. So yeah, a lot of different ways to manipulate data in Pandas. I mean, basically any way you could really want to, and we can mix and match. And really, I think the way to think about it is, our data as kind of that cube with different indexes, and we can actually transform that cube in any way we want. Flatten, we can actually expand it along one dimension, yeah, we can do all of that in Pandas.